Guys, what's up? So this is a short video where I, show how to simulate this cake eating problem with bounded time preferences. So I'm just going to go through, each one of these cells first before we get into, some more exciting stuff, which is like, as you just seen, how we get these charts here. So we have our initial cake size over here, which I just put to 100, our period, which is just our time index. Our time preferences, right, initially is determined just, from a random variable picked from a uniform distribution. And then, it follows this sort of process, right, where it is, the previous value plus some random normal variable with, a mean and a variance of the following. I know the variance, it makes this distribution, pretty flat, but that's just, to get more of the wiggle action than if I were to go and put things in, a more standard normal distribution. I can actually go and show how that would look afterwards. I put actually some bounds on these time preferences because you can see here, like, some of these values go and shoot over, 1, and that's a big problem. So I just, every time it's like at 1 or over 1, I'm just going to let it go and equal this to this 0.99999. And for that, we're going to be using that for, our consumption policy over here, which is, the initial cake size times this expectation, right? So, I mean, this expectation here is, it's just going to be the future value in that context, and really what they expect that value should be. So they act on that sort of information. And, the savings policy, looks similar to that over here. So let's go and start clicking and let's see how that looks. So we can get some really nice shapes over here given these non-stationary processes. They almost look like your regular cake eating problems, aside from this one over here, which comes in the case where we have this sort of process that you're going and following for your time preferences here. And that's something that is really, really, really interesting and really cool because it goes and it shows, a little bit more of a behavioral sort of circumstance, right? Like, let's say you went and you had an investment, right? Or you bought something that you're really, really interested in, initially, right? Which is shown in this curve here. And then, you start to lose interest over time, and then you actually stop, being interested in that resource altogether. Then all of a sudden, you get more interested in that sort of stuff. So I get that peak over here. But since this is a fixed resource, it's going to start, climbing down, even though, you have this sort of thing over here. So, I mean, even though there's a little bit of an uptick over here, you can't really have much of a uptick there. In terms of if we were going to change this over here to a random normal distribution, so let's go and pick, it's going to be a random probability, and you're going to have a mean, let's say 0.01, and let's go and, yeah, I mean, it doesn't really matter, mean of, let's say 0.01, and standard deviation 0.02. I mean, I probably shouldn't go and do that because that would just go and mess it up. Actually, so let's just go stick for, choosing a uniform distribution. But here, let's go and make sure this is, something a little bit more realistic. So 0.5, I mean, or 0.5, yeah, that's something I think that's looks pretty normal. And let's go and see how that goes and change. Obviously, not a lot of wiggles that you're going to be going and seeing. And in fact, it looks exactly like your policy functions from your standard cake eating problem. So I hope this video was a little bit informative. I hope it, gives some insight to, what I'm trying to do. Oh, that's cool with that little shape over here. But let me know what you think. I'm always looking to go and improve what I'm doing. I could be, wrong with my approach here. Let me know in the comments.